Hi everyone. In this video we're going to be working on a 2014 AB calculus question number 5. Now remember, on this question you are not allowed to use a calculator, so we will be doing this without a calculator. So in this question you're going to notice that you have a graph, or actually it's a set of tables. And in this table they give you the function f prime, they give you g of x, they give you g of prime, and they give you all the values in between x. -2, between -2 to -1, -1, -1 to 1, 1, etc. Then they also tell you that -2 f of x is equal to 12, that's an original point, and the derivative at -2 of f prime is -5, and so on with all of these and g. So what we're going to do is we're going to actually go ahead and start with question part A. It says, the twice differentiable function f and g are defined for all real numbers, x. Values of f prime, g, and g prime for various values of x are given in the table above. Find the x coordinate of each relative minimum of f on the interval of -2 to 3. Well, remember, it's all about keywords. You have to be able to figure out what the keyword in that question is. In this question, the keyword is minimum. Minimum, that's, you're working with your derivative. So what that means is if they want us to find the minimum of f, we need to be able to find f prime. But more importantly, when you have to find f prime, you have to set the derivative equal to 0 because this helps you find critical numbers. So the only time you have critical numbers is when your derivative equals to 0. So then I'm going to take my f prime, I'm going to follow it. At -2 it's -5, that's not 0. But at -1 it's 0, at 1 it's 0. These are my critical numbers. So what I'm going to do is I'm going to put all of this stuff on a number line. So for part A, I'm going to put a number line, and on my number line I'm going to put my bounds. I'm starting from -2 all the way to 3, and then the values that gave me 0, which were at -1 and 1. And then I'm just going to break up every single region. Then you have to ask yourself, okay, well, what's happening from -2 to -1? From -2 to -1, f prime is negative, so that means you're going down. From -1 to 1 of f prime, it's negative, so it's also going down. And then from 1 to 3 of f prime, it's positive, so it's going up. So in order for you to have a minimum, you have to have something decreasing and increasing, which you do here. It's decreasing and increasing, so at 1, you have a min. So we actually went ahead and found our answer. So now we just have to justify it. The table is just not good enough. You have to be able to explain it. So then you can say at x equals 1, f of x is a critical number. From -1 to 1, the function is decreasing. And from 1 to 3, the function is increasing. Sorry. Therefore, f has a relative minimum at x equals to 1. And that's your answer for part A. Okay? So use your table, create that number line. Create the number line anytime you have to find a minimum or maximum or concavity from your actual equation. So then that's going to lead us to part B. Well, part B states, explain why there must be a value c for -1 to 1 such that f double prime of c is equal to 0. Well, they want you to find, why is there a value c? Instantly, whenever you think of value c, they want you to find some point. That's the mean value theorem. And they want us to be such that f double prime is equal to 0. Well, the only way that we can go to f double prime is we have to find a derivative of your derivative, pretty much. I'm given f prime, but they want me to go to f double prime. And since they want me to answer c, they're asking you to find the derivative from -1 to 1. Well, the only way that you can find a derivative when you're given values is using the slope formula. Pretty much for part B, y2 minus y1 over x2 minus x1. So then you're going to go ahead and set it up. y2 minus y1 over x2 minus x1. But the problem is, which points am I going to pick? Well, since I'm going to f double prime, I have to pick the points of f prime. So f prime of 1 minus f prime of negative 1 all over 1 minus negative 1. Which we have because we have the values of f prime of 1, which is 0, minus 0 all over 2, which gives you 0. Therefore, because your slope from negative 1 to 1 equals to 2, there's a value from negative 1 to 1 that you're going to get a c to equal 0. And then you just have to explain that. And then remember, anytime you use a theorem or and you're trying to prove something, you have to say, since f prime is differentiable, meaning you're able to find a derivative throughout its domain, and continuous, no jumps, no holes, on negative 1 to 1, the values that they were asking you to find, the mean value theorem, the theorem you actually used, says that at least one c exists such that f double prime of c will equal to 0. All you're doing is you're restating the obvious. But anytime they're asking to find a derivative and they're looking for a value that can give you a slope, you use your slope formula because all you're given are points, and then you use the mean value theorem. Okay? And then that's going to lead us to part C. Well, part C says the function h is defined by h of x equals ln f of x. Find h prime. Key word is h prime. That means you have to find the derivative of this equation right here. So then I'm going to go ahead and find that derivative. Remember, use the points that we have. So since h of x equals to ln f of x, h prime of x is equal to, well, what's the derivative of ln? 1 over the inside times the derivative of the inside. But the inside is f of x, so the derivative of f of x is just, don't overcomplicate it, f prime of x. Well, the next step is they want you to find what is the value of h prime of 3. So then you're going to go ahead and plug 3 into all of your equations. And f of 3 is 7, so 1 over 7 times f prime of 3, which is 1/2. Multiply those out, 1 over 14, and that's your answer. When you see a question like this, don't let it confuse you. All you have to do is find the derivative of h prime, and anytime you have to find the derivative of f of x, just make it f prime. Okay? And that was part C. Then going to part D, it asks you to integrate negative 2 to 3 of f prime of g of x times g prime of x. Now you'll notice you have one equation times another equation. Whenever you have one equation times one equation, you have to do a u substitution. So then we're going to actually do a u substitution, but the question is, well, what's going to be my u? Well, you have to remember your u substitution, you use always the inside. Inside meaning inside of a function. So then when I have this, I'm going to make it like this. Negative 2 to 3 f prime of u times g prime of x dx. U is equal to g of x. Find the derivative of du dx, which equals to g prime of x. Dx is equal to du over g prime of x. And then you're going to go ahead and substitute that. Negative 2 to 3 f prime of u, g prime of x, substitute dx for du, which you found over here, over g prime of x. And you know you did it right because these g primes cancel out, which leaves you with negative 2 to 3 of f prime of u du. And then just ask yourself, what is the integral of f prime? The integral of f prime is f of u, and then your balance become 3 negative 2. But the thing is, I can't keep u. I have to actually substitute u back into the equation, which u is gx. So this becomes f of gx from 3 to negative 2. And that's your equation, where you're going to actually go ahead and substitute everything in. You're going to substitute f of g of 3 minus f of g of negative 2. Remember, this is called the fundamental theorem of calculus. And then you're going to just solve it. What is g of 3? Well, look at your table. G of 3 is 1. So f of 1 minus g of negative 2. G of negative 2 is negative 1. And then plug it in. What is f of 1? 2 minus f of negative 1, 8, which just gives you 6. So the hardest part on this table is the fact that you had to know when you're trying to find the antiderivative of from negative 2 to 3 of f prime of u, g prime of x, because this equation, which I'm going to keep on the side, had an equation times an equation, you knew that you had to do u substitution. Your u would happen to be in the inside, so that when you found your derivative of u, you got du over g prime of x, which would end up canceling this out, which it did here. Now, when you're integrating f prime, remember, the integral of f prime is just going to leave you to fu, okay, f of u. And then you're going to work it out, plug the u back into it after you find your antiderivative, and then plug in your upper bound minus your lower bound, which is a fundamental theorem of calculus. Look at the table, g of 3 was over here, and then just work it out. Thanks for watching, hope it helped. Good luck.